Come on.
This isn't natural.
Other way.
So I left the operating theatre behind for the frontiers of skin science. This is not what I'd envisaged. Along the way, I discovered a diet that could potentially help us all look younger.
How old do you think you look? What do you think people would?
Where's the box of tissues, please? That we may be on the verge of changing summers forever. So that's a cornea coming off. With the contents of a squid's eye.
Oh, there we go.
And that something we all love to eat is revolutionizing the science of how our skin ages. Skin, believe it or not, is an organ, just like the heart, lungs, or liver. But what makes it so special is that unlike most other organs, you can see it in all of its remarkable glory. It's the largest organ in the body. In fact, laid out flat, it's as big as this. And that is somewhere around 20 square feet. But it's not just big, it's the very first organ we developed. In fact, skin is the difference between a collection of cells and an individual organism. Our skin defines us. It's the first thing I look at when making a diagnosis. But why do some people look older than they are? And others younger? So, what's the scientific truth about youthful-looking skin? Time for me to declare my personal interest. I'm 44 years old, and I've not had any plastic surgery. I'm probably a bit like you. I'm young enough to care, old enough to know better. So for me, it's going to be all about the scientific facts, the evidence. If it stacks up, if it's credible, then maybe I'll believe it. Every day of our lives, our skin is engaged in a relentless war with the world around us. The first battle is against the unseen power of the sun's rays. Working out how the sun helps to make you look older means investigating the effect it has on your collagen. This is what gives young skin its youthful plumpness. When it deflates, the skin wrinkles and sags. Surprisingly, scientists trying to understand how you can look younger for longer have been studying lorry drivers.
Turn left here, Robert.
Meet Rob and Alan. Between them, they've been driving around Britain and Europe for over 50 years.
Would you like to come round the other side and get in?
Thank you. Just as well I'm sensibly dressed.
Perfect shoes. Driver wears horses as well, you say. All right.
And there's something about their faces that provide clues about the hidden power of the sun. So Rob, good-looking guy like you?
Thank you very much.
Tell me about your skincare regime. What do you use?
I apart from washing my face with soap and water, I don't use any.
All right.
None at all.
Moisturiser?
No, I've got a feeling my wife would start getting a bit suspicious if I started using moisturiser all of a sudden.
Does she have reason to be suspicious?
Absolutely not, and she knows that.
So, have you had any problems with your skin? Ever get sunburned?
Not in the cab, no. I mean, I use sun protection when I'm on holiday, if we're abroad or whatever, but for work, no, never.
And so why don't you bother with sun protection or any skincare when you're driving?
Well, because you're always in the truck. You're always in the truck. I mean, yeah, you get out every now and then, but you're only going to be going from the cab over to an office or into the back of the trailer to help unload or something like that. So you're never actually in the sun for very long.
Rob never gets burned in his cab, and that's because the glass he sits behind for most of the day filters out the rays that cause sunburn. This bit of the sun's spectrum is called UVB. These rays have a very short wavelength, and so only burn the top layer of our skin. They can't penetrate any deeper, and they can't get through window glass either. Now, I don't want to seem unkind, but Rob's skin doesn't look particularly youthful. So, what's going on? To answer that question, I've arranged for Rob and Alan to have a skin check. And that's taking place here, at Manchester University's world's leading dermatology centre.
So, let's see what we've got to set up.
Conducting the test is one of Britain's leading skin scientists, Professor Chris Griffiths.
Okay, good.
He's taking Rob and Alan's picture with this very special camera. And he's been using it to uncover some of the secrets of how the sun ages our skin.
Okay, that's very good.
So, who wants to go first?
Let's get the ugly out of the way, shall we?
So, Alan, so swing round, close your eyes. Do exactly the same again. So look in the mirror. Okay. I was just getting used to your face.
What does that mean? What's wrong with it?
Great, well done.
What, if anything, will the photographs reveal about Rob and Alan's skin?
You can see on Alan's face here that there are deeper wrinkles on the right side. They're longer compared to the left side. And there's a deeper wrinkle here compared with the left side.
And I'll tell you what's really obvious to me. On the right, the eyebrow is very definitely lower, and it's lower than his brow bone. And this nasolabial line is significantly longer, and then it goes down past his lips into the marionette line. And on the other side, all you see is that slight line there. So it's much, much less elastic tissue.
Exactly.
But I think that's gruesome.
It is gruesome. Right, can we see Rob, please?
And this time it's been colour-coded, so the green lines are marking the wrinkles.
You can see straight away that's not as bad, is it? Okay.
But interestingly, considering you are younger, don't be depressed, lots more wrinkles.
Yeah, thanks.
Very fine, but there's lots more of them.
You can see there's more on the right than on the left.
The fact that one side of their face is more wrinkled than the other is no surprise to Professor Griffiths. He's conducted numerous studies into the condition of lorry drivers' skin.
So that confirms our previous work, is that people who are professional drivers, long-distance lorry drivers, get a lot of sun exposure to one side of the face more than the other.
You might think, behind the safety of the windscreen, the drivers are protected from the sun. But you'd be wrong. There's another form of sunlight that does penetrate glass. It's called UVA. It has a longer wavelength, allowing it to get much deeper into the skin. It ends up degrading our collagen. And that leads to wrinkles. Well done. Job done.
Well, not quite. What about you?
I don't think so.
Oh, that wouldn't be fair.
I don't think so.
No, I don't think that's very fair at all.
We need a comparison, definitely.
Come on, come on.
This isn't natural. Reluctantly, in the interests of science, I gave in.
Okay, great.
And I soon wished I hadn't.
Oh, that's interesting, isn't it? You've got more fine wrinkles on the right side of your face than on the left.
That is amazing.
And that's...
Because on the left, That's quite a nice picture. I'm not unhappy with that. Oh my gosh, but on the right...
You do have far more, don't you?
Lots of wrinkles.
And that's probably from everyday driving.
So it's not just truck drivers?
Not at all, no. Not at all.
I have to say, I'm truly shocked.
Well, I think that's what gets the message home, though, doesn't it?
Goodness
Now
me.
you know how I feel.
There's no question that from now on I'll be slapping on sunscreen when I'm driving. But what kind of sunscreen? The way I remember this is that UVA ages, UVB burns. So when choosing from any of the array of sunscreens, not only am I going to look at the SPF factor, but the UVA star rating, 5-star maximum protection from those aging rays of the sun. So, come what may, I'll be using sunscreen every day, whether I'm inside or out. Most of us are smart enough to make sure we slather on sunscreen under the blazing hot summer sun. But no matter how diligent you are, slapping on sunscreen isn't foolproof. The problem with sunscreen is that it keeps rubbing off. It does provide a protective coating on top of the skin, but it doesn't penetrate deep into it. So that means if you touch anyone, you lie down, you go into the water, all the protective qualities are lost. But there's a possible solution to this problem that's at the cutting edge of skin science. I've come here to Sharm el-Sheikh on Egypt's Red Sea because it's one of the best places in the world to uncover its secrets. One of the most intriguing and promising new developments is being unearthed not here, but out there, under the waves. And it's got the potential to change summers for each and every one of us. Damaging UVA rays can penetrate water as well as glass. So why doesn't everything in the sea suffer from sun damage? According to Dr. Paul Long, who's one of the world's leading experts in biochemical adaptation, the answer lies on this stunning coral reef. Coral is a biological wonder. It's hard to get your head round, but it's a strange mix of plant and animal. The plant half of the creature gets its energy from the sun through photosynthesis. And that creates a problem for the animal half.
Well, if you think about it, photosynthesis needs sunlight, doesn't it? So this restricts coral to where they can live. So they can only live in the first couple of metres of water, because otherwise the sunlight won't penetrate through the water column. But at the same time, it's a double-edged sword, yeah? They want to live by photosynthesis, but they're also, potentially open to damage.
But the coral isn't actually damaged by the sun. And that's because the plant half, the algae, makes a sun protection compound that's passed on to the animal half.
What they do is they produce these compounds called MAAs, or microsporin-like amino acids. And what we actually found is that it really is a partnership between the two of them, the plant and the animal. So the plant will make a certain compound, pass it over to the animal, which will change it into these sun-screening compounds for the benefit of both partners. So both of them get protected from the sunlight.
Remarkably, coral is the source of sun protection for huge numbers of creatures in the sea. Smaller fish get the sun protection compounds from grazing the reef. Bigger fish from eating the smaller fish. What I want to know is how can we get them? To solve the puzzle, Dr. Long invited me out for a special evening.
Thank you.
Which involved a close encounter with a squid.
We'll need gloves.
And there's one particular part of this ocean predator's anatomy he wanted me to look at.
So, We're going to take out this eye
That's right, yeah.
and take out the lens. Okay. No girl travels without scissors.
How many do you have?
As many as I need. I'm going to start just on the outside. So that's the cornea coming up.
This could get quite messy. The eyeball itself is actually pressurised. You've got to be careful. I know you're a great surgeon, yeah? But just be careful where you make the cuts.
Oh, I can feel it now.
You can feel it now, yeah? It's quite big. Just cut the iris.
Oh, gently.
Oh, there we go. I told you that it's pressurised. Come on, quickly. We still have the lens.
Oh, okay. Unbelievable.
Got it?
Yeah,
There it is.
got it.
That's the lens.
So what's in that
Right. So
pearl?
that's the lens. So what does the lens do in the eye of any animal?
Lets the light right through so it hits the retina.
That's right, so it focuses light onto the retina, okay?
You're still being reasonable. I'm being quite agitated. Look at this.
Okay, but it's not just visible light. It will let in UV light as well, UVA and UVB.
Oh, so it needs sunglasses.
Absolutely right. That's essentially what this is.
All right.
Okay? So the MAA compounds, the sun-screening compounds, then are concentrated in the lens, so it filters out all that damaging UV before it hits the retina.
So this is a super concentrated form of all the goodness, the MAA in the coral.
That's right, yes.
Yeah. Can I just tell you one thing?
Yes.
I don't normally squeal when I operate. That's really important for you to know.
Okay.
But to find out just how much sun protection there is in the squid's eye, I need to travel back to London and Dr. Long's lab. The lens from the eye of the squid has been broken down into an extract for analysis. It's then placed in this spectrophotometer. The results are displayed on this simple graph, and what it shows is that the compounds give the squid massive amounts of protection from both UVA and UVB.
Okay, so it's absorbing the UVA.
That's it.
So no more aging.
That's right, no more aging. UVA for aging.
It's absorbing some of the UVB, but not all of it. So
Yeah.
could I still get a bit of a tan?
You can, yeah.
Perfect. But it's protecting me from the damaging rays.
Yep.
Sounds like good stuff to me.
Well, shall I show you something else in a bit more detail?
What's even more remarkable is that in tests in the lab, they found that these compounds appear to be actually absorbed by skin cells. And that means they can't rub off.
So our work right now is to see how well,
Yeah.
using human skin, do these compounds actually get absorbed into the skin. So rather than just slapping it all over, as a normal suntan cream would be, we'd have an indelible stain. So you'd apply it, maybe just once a day, hopefully, and it will be absorbed into your skin cells. And this is what
Dr. Long is confident he can make these MAAs into a synthetic sunscreen. Slap it on once and you'd be protected all day. But because this sun protection passes up the food chain, he believes we can also get it without using a cream. Not by eating squid's eyes, but by taking a sun protection pill.
potentially what we could do is we can manufacture these compounds actually into a tablet or into a capsule, and we should be able to just swallow it.
Okay, and I know now that I would have it every day, not just when I'm on holiday, because I want to protect myself against that UVA.
Absolutely
I need
right.
all the help I can get.
That's right, yeah.
What do you mean, that's right? I'm not so fond of you after all.
If all goes to plan, the pill could be on the market in 5 years' time. And that would be a major leap forward in helping all of us keep our skin looking younger for longer. But it's not just in the science of sun protection that radical new developments are taking place. There's another area of research that's uncovering more of the secrets of how and why our skin wrinkles. And this understanding holds out the promise that we can actually do something about it. The problem is that this crucial factor in skin aging is something we can't live without. It's oxygen. We breathe it in every day, but it's highly toxic. Bioscientist Professor John Casey has been grappling with the problematic connection between oxygen and aging for nearly 20 years.
Every time we breathe, probably, I don't know, 98, 99% of that oxygen goes to burn the food that we're eating and liberate small molecules we need for cellular regeneration and what have you, and it releases lots of energy that allow our muscles to work and so on. Good thing. But there's about 1–2% maybe of that oxygen that goes down a different and dangerous side branch.
This small amount of oxygen, commonly known as free radicals, attacks our DNA. Over time, the damage starts to accumulate, and the classic signs of aging show up in our skin. Our bodies do have a defense mechanism, it's just not efficient enough.
So you have a system which is continually being slightly damaged due to reactive oxygen. Then you have another system, cell defense, which is all about correcting that damage and putting things back to where they should be. So you've got a balance.
And then what happens with aging? What happens? Is it the cell system is a little bit lower, or we're just overwhelmed by the sheer amount of...
Yeah, eventually the accumulation of damaged molecules, dysfunctional molecules, is always just that little bit greater than the rate at which you can clear the mess up. And so slowly and inexorably, the animal ages.
Professor Casey works at Unilever's Science Park in Bedfordshire. And what he's investigating is how the signs of aging that appear on the surface of our skin are caused by processes at work much deeper down.
Right, well, this will really blow your socks off. This is a fantastic set of images.
This might look like a computer graphic, but it is in fact a biopsy of real skin. The two layers are easy to see. The epidermis at the top is shaded dark. The dermis at the bottom is lighter. This is where collagen, the protein that helps to keep us looking younger, is produced. Within the dermis lie the cells that make it. They're known as fibroblasts. And they're highlighted in red in this image. They're collagen-making machines. And if you really want to understand how important fibroblasts are, you have to look at this. Filmed over 24 hours, it shows a collagen gel filled with a young person's fibroblasts on the left, compared with an older person's fibroblasts on the right.
And you can see that these fibroblasts are really struggling to shrink the gel in.
They're not moving at all?
They're not moving at all.
Hardly at all, and very slowly.
They're doing their best.
Right.
But they're nowhere near as good as the cells from a young person's skin here.
You can really only see how the collagen factory works at extreme magnification. The cell in the center of the screen is a fibroblast. The spider's web around it, collagen.
Oh my goodness.
Let's go and have a look in a bit more detail.
It's the fibroblast that makes the collagen. Crucially, in young, tight skin, the fibroblast also pulls powerfully against the collagen fibers.
So it creates this three-dimensional, tense network of collagen, which gives young skin its characteristic strength and smoothness.
With old skin, the connection between the fibroblasts and collagen breaks down.
As the skin ages, what the aging fibroblasts tend to do is to almost reject the collagen threads. So they start to round up, and the projections off of the cells start to disappear, and the collagen, instead of looking like a well-sprung network, looks a bit more like a bowl of spaghetti.
Scientists are still trying to work out exactly how oxygen keeps the clock ticking on our aging fibroblasts. But is it possible to turn back the hands of time? repair, restore, rejuvenate our skin? Part of the answer appears to lie in what we eat. Dr. Gail Jenkins has been working on what scientists call oxidative stress for a decade. And she's convinced what we consume is key to protecting and recharging our fibroblasts. And she has 4 rules to make life easier for you and me. The first rule is always look for bright colours. And one of the most important of the brightly coloured fruit and veg is the humble tomato. It's chock full of a very special ingredient.
So tomato is an excellent source of lycopene, and it's lycopene in the tomato that actually gives it the bright red colour. Excellent at absorbing reactive oxygen species and preventing oxidative stress.
Rule number 2 is look for bitter tasting fruit and veg.
So things like broccoli, for example, contains ingredients called glucosinolates. Also radishes are an excellent source of these glucosinolates. And by eating these ingredients and getting them deposited in the skin, you then allow the skin cells to defend itself. So an excellent natural source of helping your cell protect itself from aging.
Time for rule number 3. Eat lots of oily fish.
Fish is excellent for the skin, right? It contains a particular ingredient called the omega-3 essential fatty acids.
Well, we've got an awful lot of omega-3 fish to choose from.
Well, you have to choose a certain type of fish, so you're looking for the oily fish. So things like mackerel over here.
And why is the mackerel good for our skin?
So the omega-3 fatty acids that are in the mackerel have been shown to have anti-inflammatory benefits, so they dampen down inflammation in the skin cells. And anything that dampens down inflammation is good to prevent aging, because inflammation will drive oxidative stress.
Rule number 4, try to avoid starchy foods like rice, potatoes or pasta.
Oh, yeah.
But what kind of meal can you make with these natural anti-aging, antioxidant ingredients?
You've got the sharp bit pointing up. Other way.
We took the food we bought in the market back to the kitchen.
If I say so myself, very well cooked.
But winning the fight against oxidative stress would severely test the appetites of most of us.
The one big issue is the amount of the ingredients that are here. So, for example, the broccoli. In terms of the amount of broccoli we think you need to get any sort of benefit, it's about half a kilo a day.
Half a kilo?
These broccoli florets, so that's a huge amount.
But how about the fish?
The fish levels aren't too bad, so putting those two together, you would deliver a significant amount of the omega-3 fatty acids that would deliver a benefit, but it would be 2 together for 1 person.
And if we ate our 5 a day of fruit, would that cover our skin benefits?
Again, it depends on the size of the portions, but I suspect not. Really, to practically get the benefit that you need from these particular ingredients, you would need to eat much, much more.
But scientists at Unilever believe they've come up with a pill that could have all the benefits of the diet in a capsule.
This is it.
Apparently, everything that's in the antioxidant diet is in this little pill. But does it work?
Right, this is the cell culture lab, Brazil. Just about every skin cell type is growing in here.
Professor Casey and his team have been testing the contents of the anti-wrinkle pill on older skin cells in the lab.
There we go.
Fibroblasts that were dormant began to reproduce new collagen. They then ran a study of the effects of the pill on 480 older women across Europe. You can't tell everything from looking at pictures from the trial, but it's a good place to start.
This is a picture of a woman's eye before taking the pill, and this is 14 weeks later. And what you can see straight away, the quality of the skin significantly improved. The wrinkles are less long, and the wrinkles that she does still have are much more shallow. It might not be much compared to surgery, but I think it's pretty convincing for a pill.
We've been working on this for quite a few years now, but it's only now that we've got the clinical data back that we know that this really works in people, and we've tested it on hundreds of women, and we're now confident that this really does work.
Unilever are planning to publish their results in a leading peer-reviewed scientific journal. And that's it's significant, because other scientists can test their claims and see if the results are reproducible. But what you eat isn't the only approach to looking younger. There's a powerful and radical new science emerging that has the potential to completely transform our understanding of how skin ages. It's hard to believe, but one of the things most of us love to eat is a factor in determining what our skin looks like. Sugar doesn't just have the potential to make you put on weight. It can also make you look older. It's incredible to think that sugar can make so much difference.
You getting on, huh?
That's all. The effect of sugar on skin aging has fascinated biologist Dr. David Gunn. He devised a test. Working with the University of Leiden in Holland, he asked a panel of people to estimate the age of faces using standardized digital images.
If you go to a school reunion, and you always see some people there who you think maybe haven't fared so well, maybe look a bit older, and also some people who seem to have done very well and have maintained a youthful look as they've got older. So we were very interested in what the reasons were behind this variation in how old people look, and maybe what the secrets were behind why some people managed to maintain a youthful appearance as they got older.
In the study of 600 people, Dr. Gunn also measured everyone's blood sugar levels. And the link between blood sugar and looks was remarkable.
So we put people into, based on their glucose levels, whether they had low levels of glucose, whether they had the average levels of glucose or high levels of glucose. And then we looked between these three groups at their perceived age. What was really interesting was that the guys in the high group looked older than those with the average levels, and the average levels looked older again than the guys with the lowest levels of glucose, sugar in their blood. And then what was fascinating layer on top of that is when we bring the diabetics in and look to their perceived age, they were older yet again. And that's interesting because the diabetics have had the longest exposure to high levels of glucose of any of these groups.
On average, people with high blood sugar looked up to 2 years older. So, how old does my skin look? Dr. Gunn offered to run the test on me. To do that, he first needed to take a series of pictures. Thank you. But there was one small hitch.
So here's the photography room.
Marvellous.
And this is where today we're going to take 2 photographs of yourself.
Fantastic.
One thing I noticed though straight away that we're going to have to ask you to do is remove your makeup.
Oh, no. Are you sure that's strictly necessary?
It's very necessary, I'm afraid. It can hide actually how your skin looks.
That's the whole point of it. This is not what I envisaged. Does it look radically different? Okay. I think we're done.
Perfect.
Finally, the pictures were taken. And adjusted so only my skin was visible. He then mixed up the images with people of a similar skin type and age to me. And he finished by showing them to a panel of volunteers. So what were the results?
How old do you think you look? What age? What do you think people would give you?
I daren't give you a figure, in case I'm wildly out.
Okay, well, I can tell you.
Where's the box of tissues, please?
You've got some box of tissues here, but I don't think you'll need them, because you came out as 34
Oh,
years
fantastic.
of age.
I'll have that. That's fantastic. I was stunned to discover that the panel thought I looked 10 years younger.
So now, I'm dying to know what your glucose levels are, of course,
Oh.
see if, now we know you look younger than your age, whether you do have low glucose or not, so
Okay.
if you could show me that, I'd be very interested.
Okay, I do have my blood glucose here. I want to keep this. Here we go. Here's the figure, 4.5.
Okay, oh, right, okay, yep, you would be counted in the low group. So indeed, this sort of supports the data we showed that people with low glucose tend to look younger for their age.
So why do high blood sugar levels, amongst other things, make us look older? The answer lies in how the sugar becomes attached to the collagen in our skin.
Once it gets attached to collagen, it makes the collagen more brittle, more likely to break, and it's also more difficult for the skin to repair itself. And so once that occurs, then you're on your way to advanced aging in the skin.
Obviously, cutting back on the sugars in our diet is one factor in looking younger. That might help to hold back the aging process, but is there anything we can do to reverse it and make our sugar-damaged skin look younger? Our understanding of the power of sugars is totally transforming our view on skin aging. It's also creating a whole new branch of science. And I think this science, probably more than anything, holds out the tantalizing possibility of helping us look younger. The center of this new science is in Berlin. It's called glycobiology, the study of complex sugars in our tissues, which scientists call glycans. And it's not just transforming our understanding of human biology, it's also creating opportunities to change life unimaginably for all of us.
The incredible power of glycobiology is on the very brink of being realized. It starts with this, the mosquito, and the disease that's the scourge of the developing world, malaria.
It might seem improbable, but using the techniques of glycobiology to develop a vaccine for malaria also holds vital clues for solving the puzzle of how to make old skin look younger. Groundbreaking work on glycobiology is being done here at the world-renowned Max Planck Institute. I'm slightly humbled to be walking through its doors. I'm here to meet Professor Peter Seeberger. He's in charge of the cutting-edge research program and believes that the science of glycans has enormous untapped potential.
Well, glycobiology is really important. It's been only in the last couple of years that people really began to understand the importance of glycans. And right now we are seeing a huge burst in this area.
Glycans are found all over the exterior surface of our cells. And without them, our cells couldn't communicate with one another. To me, they're like a kind of essential social network. Messages for everything from making organs to growing hair can only be sent when the glycans connect. Block that connection, and the dialogue is effectively turned off.
Hello.
Inspired, Professor Seeberger used this insight to develop a vaccine for malaria. What he did is revolutionary. He made synthetic glycans that block the toxin of the malaria parasite.
The parasite cannot survive without the glycan. The glycan is really important in its life cycle. And there's another aspect of our work. We do not actually try to kill the parasite. We only block its toxin.
So the parasite is still there, but it's no longer causing any symptoms or bad effects on the host.
That's right.
I'm really astonished to discover that in lab tests, the vaccine has proved 100% effective. So the painstaking work carried out here could end up saving millions of lives all over the developing world. And cracking the code of how our cells communicate is radically altering our understanding of how and why our skin ages.
On a young person's skin, the glycans are different from an old person's skin. And so the question is, what happens with this communication between cells? And the interesting part what was found is that if those glycans go away, the interaction that they involved in can't happen anymore, and that eventually leads to all sorts of detrimental effects on the skin.
So a breakdown in this communication appears to be a key variable in how the skin ages. I suppose it was only a matter of time before the huge potential of this new language of life was used to see how it could help us all look younger. The focus of this research isn't here in Berlin, but in the style capital of Europe, Paris. Secretly hoped that this investigation into glycans and looking younger would be carried out near the Boulevard Saint-Germain or the Champs-Élysées or any other of the celebrated fashion districts of the capital. But my window shopping was short-lived. I had to leave it behind and make my way to the outskirts of the city. Here, amongst the warehouses and small industrial units, are the science labs of L'Oréal. They've been studying glycobiology to see if it can be used to make skin appear younger. Of all the cosmetics companies, they are at the forefront of this science. The man leading the project is Dr. Bruno Bernard. For him, glycans are on the verge of a revolution in biology.
Glycans are involved in all the major biological processes in all human tissues, skin included, of course. Without glycans, you cannot live.
L'Oréal lead the world in manufacturing synthetic skin. They can create the two separate layers of the skin, the dermis and the epidermis, in the lab. And what they're investigating is how these two layers are connected, how they interact with each other. That communication takes place in the dermal-epidermal junction, which is rich in glycans. But as we get older, our glycans start to dwindle. The messages to keep making vital collagen don't get sent. And so the collagen starts to deflate. The skin wrinkles and sags. What L'Oréal claim is that in the lab they've been able to switch aging glycans back on, restoring the dialogue between the dermis and the epidermis.
What we have shown that when you treat the skin with some ingredients, you're able to restore the quality of the dermal-epidermal junction. In other words, you are restoring the quality of the dialogue between epidermis and dermis and epidermis. This is key.
L'Oréal have used that science to make a cream, which they say increases the number of glycans in the dermal-epidermal junction. This should restore deflated collagen, eliminate sagging, and push out wrinkles. Now that's a pretty big statement. The woman in me is obviously very excited, but the surgeon in me is skeptical. And that's because most cosmetic creams just don't penetrate deep enough or contain enough active ingredients. But maybe glycans can reach the parts other cosmetic creams can't. L'Oréal have conducted a series of tests on real skin, and I'm going to have a look at some of the results. Looking at this dermatology trial of patients before and 1 month after using the product, what you can see in this classic crow's feet view is that the lines are certainly less long and shallower, and the skin quality certainly seems to have improved around this.
This is a very difficult under-eye area where the skin is really thin, and I've not seen results this good even with microdermabrasion or with laser treatment. Before you think of buying this cream, this study by L'Oreal only featured 60 women, and it hasn't been published in a peer-reviewed journal. It's certainly promising, but I'd like to see more data to convince me. What I'm really excited by is the power of the fundamental science that lies behind it. It's a project that Professor Peter Seeberger, one of the pioneers of glycobiology, has been employed by L'Oreal as a consultant on.
Being very cynical in the beginning, I was really worried about the level of science that would be done at a cosmetics company. But I actually learned that it's very good basic science. They have people there that have been doing glycobiology for 25 years in some cases. They're employing the same techniques that would be employed in academic laboratories.
If we're being honest, I think a lot of us would like to look younger if we could. But time only flows in one direction, and its tracks get etched on our skin. As a surgeon, I've always believed in the power of the scalpel. But I know it's not the only answer. I didn't know what to expect when I started out on this journey. The influence of diet on skin aging was a real eye-opener, but it's made me much more thoughtful about what I eat. I was also pretty disappointed at just how strong and direct an effect sun exposure has on wrinkles. But I'm really hopeful that the new science of glycobiology will completely change the way we deal with skin aging. Wrinkles may never become a thing of the past, but it's really nice to believe they may be pushed further into the future.
Taking a journey to the bottom of the sea with Richard Hammond here on BBC HD at 8 o'clock tomorrow night.